Alright, so in this video we're going to work on the Unit 2G handout, but before we do that I want to go back to that reasons handout that we've been working on. And at this point we've done numbers 1 given up through number 9, definition of supplementary angles. And so we're going to do the next page, definition of perpendicular lines is number 10. That's where we're starting. Okay, and since it's a definition, I mentioned in class, definitions each have two ways of thinking about them. You've got one way that you come up with, and then you have essentially the converse of that way as well. So the definition of perpendicular lines, let's say that you start out with some perpendicular lines. So AC is perpendicular to BD. So for whatever reason, you know AC and BD are perpendicular. So then the next step in the proof could be, well, we know that perpendicular lines make right angles, and right angles are 90 degrees. So you can pick whichever angle you want here and say, let's say that we picked AEB, and you can say, okay, well, that's 90 degrees. Now, if you wanted to, you could get more technical and say, oh, it's a right angle, because that's what perpendicular lines do, and then say, oh, and a right angle is 90 degrees, because that's what a right angle is. I skip that and I go straight to 90. Definition of perpendicular lines. Okay, and if I had told you instead that angle AEB was 90 degrees to begin with, for whatever reason, then you could have told me, if you had just known that was 90, then you could have told me, oh, then these lines must be perpendicular. So AC would then be perpendicular to BD because of the definition of perpendicular lines. Okay, number 11 is vertical angles are congruent. So in this one, the vertical angles are actually, like if you can form an X shape, they're the ones that are opposite each other. So these guys are vertical angles, and then separately, these guys on the sides are vertical angles too. So the way that this appears is, it doesn't really matter what comes before it. What matters is that 1 and 2 are actually vertical angles, and if they are, then you could say that they're congruent. You can also use the measurement version. Measurement angle 1 equals measurement angle 2. And the reason is vertical angles are congruent. Okay. Then 12 and 13, if you look at them, we did a homework problem related to this stuff, and they are converses of each other. So the first one says if two lines are perpendicular. Okay, so that means that's how it starts. So that means we already have to know that AC is perpendicular to BD for whatever reason. Well, if they're perpendicular, then they form congruent adjacent angles. Okay, so let's pick a couple of angles, like this one and this one, and they're congruent and adjacent. So then you can say that angle AEB would have to be congruent to angle CEB. And then this would be the full reason right here, but it's kind of a lot to write. So instead I'm just going to say perpendicular lines lead to congruent adjacent angles. Really the way to read this is if you have perpendicular lines, then you get congruent adjacent angles. So that's how that appears. Let me fix that one up. A, E, B. Okay. And then in the next one, if two lines form congruent adjacent angles, so I've got my two lines here and here, and if they form congruent adjacent angles, then this one has to equal this one. Okay. We'll pick those two. So if you happen to know that the two lines formed angle AEB and angle BEC, and you knew that they were congruent for whatever reason, then you can say that the two lines that formed them have to be perpendicular. So then you can say AD is perpendicular to BC. Whoop, not AD, sorry. AC is perpendicular to BD because two lines that form congruent adjacent angles, those lines end up being perpendicular. Okay, so that's my way of abbreviating those things because it's sort of a pain to write the whole thing out every time. And then number 14 is one that we also talked about at some point in class. And it says if the I don't know why that went down there. If the exterior sides of two adjacent angles are perpendicular. So here are my two adjacent angles, 1, 2, right there. And if the exterior sides of them, so the outer sides, this guy and this guy, if they're perpendicular, so if AB is perpendicular to BC for whatever reason, then these two angles are going to be complementary. So I'll use the this. Then angle ABD and angle DBC are complementary. And the reason is because of this. If the exterior sides are perpendicular, then you get complementary angles. And that's my way of abbreviating that one. So that's it for this page. So we'll keep this stuff in mind as we work our way through some of 2G. Okay, so in 2G, the first given is that BA, right here, is perpendicular to AC, right there. So that's given. So we use this one. So I'm going to cross it off. So then the next step says 1 and 2 are complementary angles. So here's 1 and here's 2. And that's not the given. The given is 1 and 3, right? So somehow 1 and 2 are complementary angles has to come from this step here. So let's go back and look at what reasons we have that say you start with perpendicular lines and so you get complementary angles. So if I come back over here, let's see. Here's one that starts with perpendicular lines, but you don't get complementary angles, you get one 90-degree angle. So it's not that one. Here's one that says you start with perpendicular lines and you get congruent adjacent angles. But we don't have congruent adjacent angles. Not back here. We've got angle 1 and angle 2. So here's another one that starts with perpendicular lines. And this one says you get complementary angles out of it. So that's the one that we want. We have perpendicular lines, we get complementary angles out of it. So that's the one that says if the exterior sides of two adjacent angles are perpendicular, then you get complementary angles. Okay? So the next step is completely blank. But let's think about what 1 and 2 are complementary means. Well, complementary angles add up to 90. So, and if you come back over here, you can kind of look. Okay, where's something that says you start with complementary angles? Right? So you keep going. This one starts with supplementary angles. This one starts with complementary angles. And if you have complementary angles, then you can say that they add up to 90 because that's the definition of complementary angles. Let's come back over here. 1 and 2 are complementary. So measurement of 1 plus measurement of 2 equals 90 because that's the definition of complementary angles. Okay, so these three steps kind of go together. They sort of form their own little chunk, right? Okay, so I'll switch colors now because now we're starting the new given. Angle 1 and angle 3 are complementary. Okay, well if they're complementary, then just like I did with step 2 and step 3, I can say measurement of 1 plus measurement of 3 equals 90 degrees. For the same reason that I just did, step 2 and 3 are related, step 4 and 5 are related. So that's going to be definition of complementary angles again. So now I've got these two steps go together. Okay, so if you look at the next step says you got to use substitution. So let's try and figure out what we can substitute. By the way, we've now used this one too. So I'll choose another color because we're starting a new chunk of the proof here. So substitution, we need two things we need to replace one thing with another thing. Well, if you notice, we've got a 90 here and we got a 90 there. So anywhere that a 90 appears, I can replace it with one of the other terms. So why don't we replace the green 90 with this, right? Because the blue box also equals 90. So if I do that, then I get the M1 plus M2. Instead of saying it equals 90, I'm going to say it's equal to M1 plus M3. Okay. So there's my substitution step. We've done a lot of problems now where, oh, two things equal 90, so let's set them equal to each other. Or two things equal 180, so we'll set them equal to each other. Okay, now, I'm not sure what we're going to do in the next step, but if you look right here, the thing that we're trying to prove is that measurement of 2 equals the measurement of 3. That's what we want to prove. And if you look at the step in 6, well, we've got 1 plus 2 equals 1 plus 3. So if we could get rid of the 1s, then we've got what we want. We've got what we're trying to prove. So in order to get rid of the 1s, we're going to subtract them from both sides. So I'm going to say that the 1 on this side is equal to the 1 on that side. And remember, anytime something equals itself, it's called reflexive. So then you can take step 6, subtract step 7, and you get what you're trying to prove, step 8. So this is going to be subtraction. And then I'm going to write down next to it that we're actually doing line 6 minus line 7 gave us line 8. Right there. Okay? So let's try the next problem. Okay, so the next problem is another one of these justifying statements problems. So the given info right here is that O is the midpoint of AD, and angle 1 and angle 2 are congruent. So it's kind of like if you were working on a little mini proof over here. O is the midpoint of AD is given. And so the midpoint might lead you to other things. And then the other given is angle 1 is congruent to angle 2. And that might lead us to other things too. Okay, so let's take a look at our first one here. FOA plus AOC, those two angles added, the measures added together is 180. So FOA is right here. AOC is right here. And it's saying if you put those two angles together, you get the big angle, which is 180. Okay, so if you come back to your reasons, it turns out that that's the special case of the angle addition postulate right here. You add the two angles that are right next to each other, you get the big angle. So that's angle addition postulate. Okay, and the next one, we've got FO plus OC equals FC. And hopefully by now you've got that down. If you add two little segments that are next to each other to get the whole segment, that's going to be called the segment addition postulate. Okay, part C says you've got three angles added together to get 180. So let's look at where those three angles are. We've got EOD right there. ODE is this one right here. And DEO is this one right here. And they add up to 180. Well, we've talked about this before, but we haven't really formally stated it as one of our reasons. It turns out this is on the last page here. The sum of the interior angles of a triangle is 180. That's the formal way of saying it. In class, we've just been saying, oh, because triangles have 180 degrees. So the shortcut for writing that, I'll let you get away with just writing triangle equals 180. Okay. So far we haven't actually had to use the given info yet. Okay, let's look at D. FOA is congruent to COD. Here's FOA right there. Here's COD right here. So if you notice, those are vertical angles, right? So this is because vertical angles are congruent. In part E, let's see, it says, since FOA and DOF sum to 180, then they're supplementary. So the since you can interpret as though you already know it in a proof. Measurement of FOA plus measurement of DOF equals 180. Pretend that's given. You already know it for some reason. So then the next step is, so FOA and DOF, those angles are supplementary. Well, if we come back and we to our reasons and we look for one that says, what says you can take two angles added together and then get supplementary angles? Well, let's go back up here. This has two angles added together, but then it never says so you get supplementary angles. This one says you have two angles added together to get 90, so you can say they're complementary angles. This one says you start with 180, two angles that add to 180, so you get supplementary angles. Definition of supplementary. So this one right here, definition of supplementary angles. Okay? Let me erase this. The next one says, if measurement of COD is 90, then FC is perpendicular to AD. So the way that you read the if is you pretend that's given also. So in a proof, we'd say COD is 90 for a given reason, or whatever reason really. So then the question is, why is FC perpendicular to AD? What allows us to state that? So if you go back to your reasons, we're looking for a measurement equals 90 leads to perpendicular lines. And so if we come down here, a measurement that equals 90 gives us perpendicular lines. That's what perpendicular lines are. So this is definition of perpendicular lines. Okay. The next one says AO equals OD. Okay, in order to know that, you have to know that O is the midpoint, which we do. It's right here. So then the question is, why can we then say AO equals OD? Whoops, OD. Well, let's look at what says start with a midpoint and then get one side equals the other side. So let's go back up here where the midpoint stuff is. And the definition right away says if you have a midpoint, then one side equals the other side. The other option that you have is you have a midpoint, so one side equals half the whole thing, which is not what we just said. We over here in 2G are saying one side equals the other side, so that's going to be definition of midpoint. Whereas in the next step, in H, it says AO is half of AD. That's the other version. That's the midpoint theorem right there. Okay. Angle 1 is congruent to angle 2. That's a given. So, and in the picture, there they are. And then J says OB bisects AOC. OB bisects AOC. Well, in order to know that, you either have to be given it, which we're not, or you have to know that 1 and 2 are already congruent, and then you can say, so OB bisects angle AOC. So the question is, what says start with a couple congruent angles, get an angle bisector? So if we come back over here, well, definition says start with a couple congruent angles, get an angle bisector. That's the definition of angle bisector. So that's what this one's going to be. Definition of angle bisector. Okay, and then the last one here, if FOA is congruent to FOD, so here's FOA, and if it's congruent to FOD right here, so I'll do 2 for each. Okay, so that's kind of like we're doing a mini proof, and we say we already know FOA is congruent to FOD for given, because of given, or whatever reason we figured out to get it. Okay, so if that's true, then why do we get perpendicular lines right afterwards? FO perpendicular to DA. So look at the picture, and those two angles are right next to each other that we marked here and here. So the question is, why do those two angles next to each other give us perpendicular lines? So let's come back to our reasons and see which ones lead to perpendicular lines. So this one leads to perpendicular lines, but it doesn't start with a couple congruent angles. It starts with a 90-degree angle. So it's not this one. This one ends in perpendicular lines. And it says you start with a couple angles next to each other that are congruent, and they give you perpendicular lines. Well, that sounds pretty good to me. So this one so far looks good. And then that's it. That's all we have that leads to perpendicular lines. So it's going to be this reason right here. So let me go back. Two lines that form congruent adjacent angles. Those turn out to be perpendicular lines. Okay. So then number 3 says, let's say you were working on a proof using this diagram up here. Right up there. So I'm going to copy this diagram here. Edit, copy, and then I'll paste it down here somewhere. And let me move it over so you can see it a little bit better. Why isn't that working? I'll just scroll over. There we go. Okay. So, while you're working on some proof, you figured out, for some reason, that AO, right here, is perpendicular to FC right here. Okay, so you're told that they're perpendicular. For whatever reason. We don't know why. So then the question is, what could come after that? Okay, well, let's go back to our reasons and see which ones start with perpendicular lines. So here's one that starts with perpendicular lines, and then you can follow it up with, so I get some 90-degree angles. So over here, why don't we choose, I don't know, this one. So then we could say angle FOA, that measurement, is 90 degrees. You could have also picked this one, AOC, instead if you wanted to. It doesn't really matter. So it depends on the proof and what you're aiming for, really, but in this case it just says what could come next. Well, that's going to be, back here, the definition of perpendicular lines. Definition of perpendicular lines. Okay, and the next line, so that's one option. Now let's go back and see if we can come up with another one. AO is perpendicular to FC. Okay, let's find something that requires us to know that you first have perpendicular lines, and here's one right here. And that leads to congruent adjacent angles, written like this. So let's go back to 2G. Here are my perpendicular lines, and here are my congruent adjacent angles, those two 90-degree angles. So the follow-up here, so this would be perpendicular lines lead to congruent adjacent angles. So then that would say, let's see, the congruent adjacent angles, sorry, I covered up the letters here. It'd be angle FOA is congruent to angle AOC. Or you could do the M versions, right? Or measurement of angle FOA equals the measurement of angle AOC, like that. Okay, so there's a third one too that starts with perpendicular lines, and if we scroll down a little bit more, here it is. If you have perpendicular lines that form the exterior of two adjacent angles, then you can say those angles are complementary. So let's come back over here. So I've got perpendicular lines right here. Those are the exterior sides of angles 1 and 2. So if I use that same theorem, I'm going to say angle 1 has to be congruent, or not congruent. Angle 1 and angle 2 are complementary. And the reason is, if the exterior sides of two adjacent angles are perpendicular, then you get complementary angles. Okay. Now, if you think about it, you can even go one more step. If you have 1 and 2 are complementary, the next step could be, so measurement of 1 plus the measurement of 2 equals 90 degrees, because that's the definition of complementary angles. You have complements, so they add up to 90. Okay, and that's it. So hopefully that'll help as you try your homework later. All right, I'll see you in class soon. Bye-bye.